Okay, my dear students, now we continue the same topic, and you see for properties of triangles, the time duration of time is allotted is 4 clock hours. So we already completed 1 hour in which we have completed 28 problems. Now the next this 1 more hour, 2 more hours also. So now we continue the number. So problem number 29, this is in triangle ABC, if angle C is equal to 90 degrees and tan A by 2, tan B by 2 are the roots of the quadratic equation, ax square plus bx plus c equal to 0, where a is not equal to 0, then 1 b plus c is equal to a, 2 a plus b is equal to c, and 3 c plus a is equal to b, and 4 b and c are equal. So this asked actually JEE, that is JEE examination 1999. Now from the hypothesis, tan A by 2 plus tan B by 2 is equal to minus B by A, and tan A by 2, tan B by 2, C by A, because they are the roots of the quadratic equation ax square plus bx plus c equal to 0. So therefore, from this you will get A plus B by 2 is equal to 45 degrees, implies tan A by 2 plus tan B by 2 by 1 minus tan A by 2 tan B by 2 is equal to 1, which shows that minus B by A, because tan A plus tan B by 2 is minus B by A, is equal to 1 minus C by A. So which indicates that B is equal to C minus A, or A plus B is equal to C. So the correct option is option number 2. Problem number 30. The sides of a triangle are in the ratio 1:√3:2. Then the angles of the triangle are in the ratio 1:3:5, 2:3:4, and 3:2:1, and finally 1:2:3. This is JEE 2004. Now you can write that is A is equal to K, B is equal to K root 3, and C is equal to 2K. So that cos A is equal to B square plus C square minus A square by 2BC, which is equal to 3 plus 4 minus 1 by 4 root 3, which is root 3 by 2. So that A is equal to pi by 6. So angle A is equal to pi by 6. And cos B is equal to similarly sec square plus A square minus B square by 2CA, that is cosine rule, cosine formula. So if you substitute the values of A, B, C, then you get B is equal to pi by 3, and cos C is equal to, again substituting the values of A, B, C, you will get 1 plus 3 minus 4 by 2 root 3, which is 0, which is C is equal to pi by 2. Of course, cos C you need not verify, because already you got angles A is equal to pi by 6 and B is equal to pi by 3. Only whether the hypothesis is correct or not, I have checked that cos C, because already you got the two angles 3, A and B, so you will get automatically the third angle C. So correct option is option number 4. Next, the angles of a triangle are in the ratio 4:1:1. That means an isosceles triangle. Then the ratio of the longest side to the perimeter is 1√3:2 plus root 3, 2 1:6, 1:2 plus root 3, and 4 2:3. This is JEE 2003. Angles are, you can suppose the angles are 4A, A and A. So that 6A is equal to pi and A is equal to pi by 6. So angles are 120 degrees, 30 degrees and 30 degrees. And see, you know that from elementary geometry, angle opposite to the greater side is greater than all the other sides. It's not. Side opposite to 120 degrees is the longest side. So therefore, A by A plus B plus C, that means A plus B plus C is the perimeter. So largest side is small a. So small a by the perimeter is equal to sin 2 pi by 3 by sin 2 pi by 3 plus sin 2 sin pi by 6. So it is equal to root 3 by root 3 plus 2. So the ratio is simply a root 3 is to root 2 plus root 3. So that means answer is 132. If in triangle ABC, cos A cos B plus sin A sin B sin C is equal to 1, then A plus A is to B is to C, the ratio is equal to 1 is to root 2 is to 1, 2 root 2 is to 1 is to 1, 3 1 is to 1 is to root 2, 4, 1:2:3. Now here this problem actually it is asked in 1984, because why I could remember the year, even though I have not written, but I could remember that, because that is the year in which I have started giving coaching to IIT entrance examinations. So here this, even though it is a the problem in properties of triangles, but we can do this problem without using the properties of triangles formula, any formula, just by using a simple trigonometric concepts. Simple trigonometric concepts, we can work out this problem. See how I did it is. Cos A cos B plus sin A sin B minus sin A. So for the given left hand side, you add and subtract sin A sin B. Add and subtract sin A sin B in the left hand side of the hypothesis. So then you will have cos A cos B plus sin A sin B minus sin A sin B plus sin A sin B sin C is equal to 1. And you know that cos A cos B plus sin A sin B is cos A minus B. And if you take from the remaining two terms sin C common or sin A sin B common, you will get plus sin A sin B into sin C minus 1, which is equal to 1. So this indicates that sin A sin B into sin C minus 1 is equal to 1 minus of cos A minus B. 1 minus of cos A minus B. And you know that cosine and sine, the functions always lie between 0 and minus 1 and plus 1. So therefore, here 1 minus cos A minus B is greater than or equal to 0, that is right hand side, and left hand side sin A sin B are positive, but sin C is less than or equal to 1, so left hand side is less than or equal to 0. That is LHS is less than or equal to 0, but RHS is greater than or equal to 0. So therefore, each must be equal to 0. Sin C minus 1 equal to 0 and cos A minus B is equal to 0. So therefore, you will get sin C is equal to 1, namely C is equal to pi by 2, and cos A minus B is equal to 1, means A is equal to B is equal to pi by 4. So therefore, A is to B is to C is sin A is to sin B is to sin C, which is 1 by root 2 is to 1 by root 2 is to 1, which is 1 is to 1 is to root 2. So correct option is 1 is to 1 is to root 2, option number 3. So please see here, we didn't use any sine rule or cosine rule or anything, just elementary. Here the important concept is simply, technique is adding and subtracting sin A sin B on the left hand side, and observing that sine function cosine function always lie between minus 1 and plus 1. 33. In triangle ABC, if cos A plus cos B plus cos C is equal to 3 by 2, then triangle ABC can be isosceles not equilateral, 2 isosceles right angled, 3 right angled, 4 equilateral. Now in this problem also, in the solution I have not used properties of triangles, because if you use properties of triangles, the procedure will be laborious procedure for this problem. But what I used is simply the maximum value of cos A plus cos B plus cos C, trigonometric inequalities. So we prove that cos A plus cos B plus cos C is always less than or equal to 3 by 2, and equality occurs if and only if the triangle is equilateral. Equality occurs if and only if the triangle is equilateral. So for this, in any triangle, that is, and equality holds if and only if A is equal to B is equal to C is equal to pi by 3. So to prove that, so you will have cos A plus cos B plus cos C is 1 minus 2 sin square A by 2 plus 2 cos B plus C by 2 cos B minus C by 2. And you know that cos B minus C by 2 is less than 1. It's not less than or equal to 1. So that is less than or equal to 1 minus 2 sin square A by 2 plus 2 sin A by 2. That is, but this is equal to 1 minus 2 sin A by 2, 2 into sin A by 2 minus half whole square plus half. Here I have adjusted the terms. That is, the right hand side is less than or equal to that one, but that is 1 minus half 2 into sin A by 2 minus half whole square plus 1 by 2. So that is 1 plus half is 3 by 2, 3 by 2 minus 2 into sin A by 2 minus half whole square, and which is always less than or equal to 3 by 2. Equality occurs holds only when sin A by 2 is equal to half or A is equal to 60 degrees. So similarly you can prove that B is equal to C is equal to 60 degrees by writing here cos A plus cos B plus cos C, you have written 1 minus 2 sin square a by 2. For the remaining, you have written cos b plus cos c. For the second one, what you look at, you write cos b as 1 minus 2 sin square b by 2 and cos a plus cos a as 2 cos e plus a by 2 c minus a by 2, like that. So, similarly, we can show that b is equal to c is equal to 60 degrees. So, the triangle is equilateral. So, to prove this, what you have proved in general, we have proved that in triangle ABC, cos A plus cos B plus cos C is always less than or equal to 3, 3 by 2. Cos A plus cos B plus cos C is always less than or equal to 3 by 2. And for this problem, in some textbooks and some teachers also, they tell that they are giving a very simple, very simple proof. Namely, the proof is cos A plus cos B plus cos C is equal to 3 by 2. So, therefore, they conclude that cos A is equal to half, cos B is equal to half and cos C is equal to half. So, that A, B, C are equal to 60 degrees. That is very simple. If three positive numbers whose sum is 1 by 2, 3 by 2, we cannot conclude that each number is equal to half. Understand? So, that is not a good proof. That is not a proof, not at all a proof. 34. If the sides ABC of triangle ABC satisfy the relation 2a square plus 4b square plus c square is equal to 4ab plus 2ca, then cos b equals 1, 1 by 8, 2, 3 by 8, 3, 5 by 8, 4, 7 by 8. This is what is called NYSMC. NYSMC means New York State Maths Competitions. New York State Maths Competitions, that is USA. That is, of course, it was asked in 1985. So, here the relation is, if you are given such problems, then what you do is, you try to see that from the entire hypothesis, you show that sum of squares of numbers is equal to 0, so that each is equal to 0. So, that is the idea behind these such problems. So, the hypothesis 2a square plus 4b square is equal to plus c square is equal to 4ab plus 2ca, we can write it as c minus a whole square plus a minus 2b whole square equal to 0. Because if you bring to the right hand side to the left hand side, you will have a square minus 2ca plus c square plus a square minus 4ab plus 4b square equal to 0, which indicates that c minus a whole square plus a minus b whole square equal to 0. So, therefore, c is equal to a and a is equal to 2b. So, therefore, cos b is equal to c square plus a square minus b square by 2ca, that is, but c is equal to a and a is equal to b, 4b square plus 4b square minus b square by 2 into 4b square, which is 7 by 8. So, correct option is number 4. Next, 35. ABC are the sides of triangle ABC such that a square, b square, c square are the roots of, here see, the equation, cubic equation x cubed minus px square plus qx minus r equal to 0. Then cos a by a plus cos b by b plus cos c by c equals 1 p by 2 root small r, 2 p by 2 r, 3 p by r root 2 plus, 4 p by small r. So, now by hypothesis, because p, q are the roots of so and so equation, we are having a square plus b square plus c square is equal to p, and sigma a square b square is equal to q, and lastly product of the roots a square b square c square is equal to r. Now, we know that cos a by a is b square minus c square by 2abc, cos b by b is equal to c square plus a square by 2abc, and cos c by c is equal to a square plus b square minus c square by 2abc. Of course, here cos b by b it's not printed, and cos c by c is not printed, but that is cos by as per the hypothesis, that is cos a by a plus cos b by b plus cos c by c is asked. So, therefore, sigma cos a by a is, if you add all these with common denominator, the common denominator is 2abc, a square plus b square plus c square by 2abc, that is nothing but, p is nothing but a square b square. A square, say a square plus b square plus c square is p, because a square, b square, c square are the roots of that equation. So, and a, b, c are a square, b square, c square is equal to r square, r. So, therefore, this is equal to p by 2 root small r, because a square, b square, c square are the roots of x cubed minus px square plus qx minus r equal to 0. So, correct option is option number 1. Next, 36. Here, this is a very good problem. In triangle ABC, the medians AD and BE intersect at right angles. If BC is equal to 7 and AC is equal to 6, then the length of the side AB is 1, 4, 2 root 17, 3, 2 root 5, 4, 3 root 7. Now, and you know that the point of intersection of the medians is called the centroid, and it will be denoted by capital G. So, suppose, see, and everybody knows that the centroid divides a median in the ratio 1:2 from base to the vertex, or 2:1 from the vertex to the base. So, here suppose DG is equal to X, and so the and EY, EG is equal to Y, EG is equal to Y itself. So, that AG is 2X and BG is equal to Y, because the centroid divides the median in the ratio of 2:1 from the vertex to towards the base side, or 1:2 from the base side to towards the vertex. So, therefore, AG is equal to 2X and BG is equal to 2Y. Now, you can use Pythagoras rule. Now, from triangle AGE, in triangle AGE, angle G is 90 degrees. So, you will get AG square plus DE square is equal to AE square. So, that is AG square means 4x square plus DE square means y square is equal to 3 square, because AC is given to be 6. So, A is equal to 3. So, therefore, 9. That is number 1. Again, from triangle BGD, we have BG square plus GD square is equal to BD square, which is 4y square plus x square is equal to 7 by 2 square, that is 49 by 4, because this is the midpoint of BC, and BC is given to be 7. So, therefore, adding 1 and 2, you will get 5 into x square plus y square is equal to 9 plus 49 by 4, which is 85 by 4. So, therefore, x square plus y square is equal to 17 by 4. 17 by 4 itself. So, now consider the triangle AGB. In the triangle AGB, you know the AG is equal to 2x and BG is equal to 2y. So, if you use again Pythagoras rule, 4x square plus 4y square is equal to AB square. AG square plus BG square is equal to AB square. That means 4 into x square plus y square is equal to AB square. So, but 4 into x square plus y square is given we obtained 17 by 4. So, 4 into 17 by 4 is AB square. So, therefore, AB is equal to root 17. Option number 2. Right. 37. A and B are acute angles of triangle ABC such that 3 cos square A plus 2 cos square B is equal to 4, and 3 sin A by sin B is equal to 2 cos B by cos A. Then the measure of angle 2B is 1 pi by 4, 2 pi by 6, 3 pi by 2, 4 pi by 3. Now, come on, see. 3 cos square A plus 2 cos square B can be written as, now this 4 you write as 1 plus 3. So, it can be written as 2 cos square B minus 1 is equal to 3 into 1 minus cos square A. In 1 to the left hand side and bring 3 cos square A to the right hand side. So, that you will get 2 cos square B minus 1 is equal to 3 into 1 minus cos square A. So, that implies cos 2B is equal to 3 sin square A, number 1. Now, also you have 3 sin A cos A from the second hypothesis. 3 sin A cos A is equal to 2 sin B cos B. So, that means 3 sin 2A is equal to 2 sin 2B. Multiply both sides with 2. Then you will get 3 sin 2A is equal to 2 sin 2B, number 2. Therefore, cos of A plus 2B is equal to cos A cos 2B minus sin A sin 2B, which is cos A into cos 2B means 3 sin square A, minus sin A sin 2 means minus sin A into 3 by 2 sin 2A, from 1 and 2. From 1 and 2. So, that is equal to 3 cos A sin square A minus sin A into 3 sin A cos A. So, that means 3 cos A sin square A minus 3 sin square A cos A, which is equal to 0. So, A plus 2B is equal to 90. So, the measure of the angle A plus 2B is 90. So therefore, the correct option is option number 3. In triangle ABC, AD is the altitude, of course, B greater than C. If the length AD is equal to, altitude length AD is equal to ABC by B square minus C square, and C is equal to 23 degrees, then angle B equals 110 degrees, 2 113 degrees, 3 112 degrees, and 4 111 degrees. So here in this problem, what you are given the hypothesis, you are given small b is greater than small c. That means AC is greater than AB. And also the altitude length you are given to be altitude length, altitude drawn from A to the opposite side BC is ABC by B square minus C square. Then you are asked that and C is equal to 23 degrees, then you have to calculate angle B. Now come on, see the diagram. Using the sine rule for triangle ABD, where AD is the altitude, for the triangle ABD, you will get sine B is equal to AD by AB, that is AD by C, or AD is equal to C sine B, so that C sine B is equal to AD, but AD you are given that ABC by B square minus C square. So therefore, sine B is equal to sine A sine B by sine square B minus sine square C. CC cancel it, and for AB you write A sine 2R sine A, 2R sine B, so that you will get sine B is equal to sine A sine B by sine square B minus sine square C. So that indicates that sine B plus into sine B minus C. Of course, again sine B cancel. Sine B plus into sine B minus C is equal to sine A. So therefore, sine B minus C is equal to sine B plus into sine B minus sine A. But sine B plus C is sine A. Cancelling, sine B minus is equal to 1, or B minus is equal to 90 degrees, or B is equal to B minus is 90 degrees. So B is equal to C plus 90, but you are given C is equal to 23 degrees. So therefore, 23 plus 90, 113. So 113 degrees. The option is number 2, 39. Now if A cos alpha, A sin alpha, B A cos beta, A sin beta, C A cos gamma, A sin gamma are the vertices of an equilateral triangle, then 1 cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 into cos alpha plus beta plus gamma, tan 3 alpha plus tan 3 beta plus tan 3 gamma is 0, is equal to 3 tan alpha tan beta tan gamma, sin 3 alpha plus sin 3 beta plus sin 3 gamma is 3 sin alpha sin beta sin gamma, and none. Now you can see that what is the vertices A cos alpha, A sin alpha, A cos beta, A sin beta, A cos gamma, A sin gamma. So these two vertices indicate that the origin is the circumcenter of the triangle. Origin is the circumcenter of the triangle. So that means OA is equal to OB is equal to OC, each is equal to A. So that triangle ABC is inscribed in the circle x square plus y square is equal to A square. Triangle ABC is inscribed in the circle x square plus y square is equal to A square. You can see that is A, the point is A cos alpha, B A sin alpha. This is x and this is y. X square plus y square is equal to A square into cos square alpha plus sin square alpha, which is equal to A square. So the triangle is inscribed in the circle x square plus y square is equal to A square, and the center of the circle is origin. So since the centroid of triangle ABC is origin, equilateral triangle, because it is an equilateral triangle you are given to be. The given triangle is also equilateral. For an equilateral triangle, the centroid, orthocenter and circumcenter, incenter all will be same. So therefore, you will get, since the circumcentroid is of triangle ABC is origin, we have A into cos alpha plus cos beta plus cos gamma is equal to 0, is equal to A into sin alpha plus sin beta plus sin gamma. So you will get sigma cos alpha is 0 and sigma sin alpha is also 0. So from this you will get cos 3 alpha, sigma cos 3 alpha is 3 into cos alpha plus beta plus gamma, and sigma sin 3 alpha is equal to 3 into sin alpha plus sin beta plus sin beta, 3 into sin of alpha plus beta plus the gamma. Of course here sigma sin 3 alpha, that of course it's a standard problem in comparison of de Moivre's theorem, application of de Moivre's theorem, that everybody knows. It's a worked out problem in all the books. So sigma cos 3 alpha is 3 into cos alpha plus beta plus gamma, and sigma sin 3 alpha is 3 into sin alpha plus beta plus gamma. But here sin 3 alpha plus sin 3 beta plus sin 3 gamma is going to be 3 sin alpha sin beta sin gamma, which is not the answer. So the correct answer is option number 1. Now see this. In triangle ABC, the bisector of the angle A meets the side BC in D and the circumcircle in E. Then the length DE is equal to 1 A secant A by 2 by B, 2 into B plus C, 2 A square secant A by 2 into B plus C, 3 A secant A by B plus C, and 4 A square sin A by 2 by 2 into B plus C. But this is a good problem. In triangle DEC, you see the figure, angle DCE, please see, angle DCE is equal to angle DC is equal to angle BAE, because angles in the same segment. So each is equal to A by 2. And also angle DEC, this is angle DEC is equal to angle B, because angles in the same segment. So now, since AD is the median, so that BD is to DC is always C is to B. Please remember that the median of a triangle divides the opposite sides in the ratio of the other two sides. So here BD is to DC is AB is to AC. AB is to AC, which is C is to B. So that is small a is equal to BC, which is BD plus DC, that is A by B, C by B into DC plus DC. So DC is equal to AB by B plus C, and BD is equal to CA by B plus C. So therefore DE by sin A by 2 is equal to DC by sin B, implies DE is equal to DC sin A by 2 by sin B. So that means AB by B plus into sin A by 2 by sin B, which is equal to 2R sin B into sin A by 2, A into 2R sin B into sin A by 2 by B plus into sin B. So if you simplify it, then you get A square secant A by 2 by B plus 2 into B plus C. That is length of DE. DE means the segment between the side and the circle. AD is the altitude and D is the segment in which that AD while extending meeting the circumcircle. So the DE is nothing but A square secant A by 2 by 2 into B plus C. So option is correct option number 2. Next 41. In triangle ABC, if A cos A plus B cos B plus C cos C by A sin B plus B sin C plus C sin A is equal to A plus B plus C by 9R, then triangle ABC is one equilateral, two right angled, isosceles but not right angled, and difference between two acute angles is pi by 6. Okay, right. This is a good problem. See, in properties of triangles, more problems on equilateral triangles are there, because equilateral triangle satisfies so many properties. So that's why you will get more problems on equilateral triangles. Now by substituting A is equal to R sin A, B is equal to R sin B, etc. in the given relation, you will get sin 2A plus sin 2B plus sin 2C by 2 into sin A sin B plus sin B sin C plus sin C sin A is equal to 2 by 9 into sin A plus sin B plus sin C. Now sin 2A plus sin 2B plus sin 2C, you know that 4 sin A sin B sin C by sigma sin A sin B is equal to 4 by 9 into sigma sin A. So therefore, you let 4 will cancel, 9 ABC by sigma AB is equal to A plus B plus C, or 9 is equal to A plus B plus C into A plus B plus C by ABC. A plus B plus C by ABC, or 9 is equal to A plus B plus into 1 by A plus 1 by B plus 1 by C. Here there is a standard result among positive real numbers. For any positive reals x, y, z, x plus y plus z into 1 by x plus 1 by y plus 1 by z, reciprocals. So sum of positive numbers into sum of their reciprocals is always greater than or equal to square of the number of numbers. The here 3 numbers, so x plus y plus z into 1 by x plus 1 by y plus 1 by z is always greater than or equal to 3 square. 3 square means 9. So, here x plus y plus z into 1 plus x plus 1 by y plus 1 by z is greater than or equal to 9, and equality holds if and only if x is equal to y is equal to z. That means A is equal to B is equal to C. So, it shows that triangle ABC is equilateral. So, here we have used sine rule, but lastly what we have used is the AMG inequality. For any positive real numbers x1, x2, x3, xn, x1 plus x2 plus xn into 1 by x1 into 1 by y1 plus 1 by x1 plus 1 by x2, etc. 1 by xn is always greater than or equal to n square, and equality occurs is equal to n square when x1 is equal to x2 is equal to x3, each is equal to xn. So, the correct option is equilateral triangle. So, equilateral number 1, 42. Next. So, in triangle ABC, if small r1 is equal to 2 into small r2 is equal to 3 into small r3, r1, r2, r3 means x radii. R1 is x radius opposite to vertex A, R2 is x radius opposite to the vertex B, and R3 is x radius opposite to the vertex C. Then the perimeter of triangle ABC is 1, 2A, 2, 3B, 3, 3C, and 4, 3 into A plus B plus C, and which is EAPCET 2015. Now, by hypothesis, you know that R1 means delta by S minus A, and R2 is delta by S minus B, R3 is delta by S minus A. So, by hypothesis, delta by S minus A is equal to 2 delta by S minus B is equal to 3 delta by S minus C. Suppose each is equal to K, 1 by K. Then S minus A is equal to K delta, S minus B is equal to 2K delta, S minus C is equal to 3K delta. So, adding you will get 3S minus of A plus B plus C is equal to 6K delta, or S is equal to 6K delta, because A plus B plus is equal to 2S. So, now S is equal to 3 into 2K delta, which is 3 into S minus B, or 2S is equal to 3B. 2S is equal to 3B. So, what is 3 into S minus B? That is nothing but 3S, 2S, which is nothing but 3B. So, correct answer is 2. 43. In any triangle ABC, A plus B plus C into B plus C minus A into C plus A minus B into A plus B minus C by 4B square C square is equal to sin square B, 2 cos square A, 3 cos square B, 4 sin square A. So, EAPCET 2014. Now, given expression you can write it as A plus B plus C is equal to 2S, is not 2S into 2 into S minus A into 2 into S minus B into 2 into S minus A. So, you will get in the numerator you will get 16, in the denominator you are having 4. So, 16 by 4 means 4. So, that is equal to 16 delta square by 4B square C square, which is nothing but 4 into, and delta you know that half B is sin A. Delta is equal to half BC sin A. So, that is 4 into 1 by 4 into B square C square sin square A by B square C square. So, 4 cancel, B square cancel, which is equal to sin square A. So, correct option is option number 4. Right, 45. In triangle ABC, R1 R2 plus R2 R3 plus R3 R1 is 1 delta square by small r square, 2 delta by small r, 3 2 delta by r, 4 delta square. So, the EAPCET 2013. Now, the given expression is delta square by S minus A into S minus B, R1 R2. R1 is equal to delta by S minus A, R2 is equal to delta by S minus C, S minus B, and R3 is equal to delta by S minus C. Substitute. So, delta square by S minus A into S minus B, delta square by S minus B into S minus C, delta square by S minus C into S minus A. So, that is sigma R1 R2. So, therefore, sigma R1 R2 is equal to delta square into, now simplify it, S minus C plus S minus A plus S minus B by how much you will get? S into S minus A into S minus B. But S into S minus B, S minus A into S minus B into S minus C is delta square by S. So, if you substitute, that is 3S square minus 2S square. So, that is equal to S square. So, S square means delta square by R square. So, option number 1, 46. In triangle ABC, 1 by A plus C plus 1 by B plus C equal to 3 by A plus B plus C. Then angle C, again 130 degrees, 45 degrees, 60 degrees and 90 degrees. This is of course EAPCET 2013. I think This problem is again, this is repeated, but any problem, I told you the converse is also true. Now what you could do is, if you simplify the given hypothesis, a plus b plus 2c into a plus b plus c is equal to 3 into a plus c into b plus c. Now expanding and simplifying, you will get a square plus b square minus c square is equal to ab. So you will get cos c is equal to a square plus b square minus c square by 2a, which is equal to half. So angle c is equal to 60 degrees. See, I have given you a note. The converse is also true. That is, if angle c is equal to 60 degrees, then 1 by a plus c plus 1 by b plus c is equal to 3 by a plus b plus c. 47. In triangle ABC, 2 into a sin square c by 2 plus c sin square a by 2 is equal to 1 2s, 2 into s minus a, 3 2 into s minus b, 4 2 into s minus c. Now the hypothesis a 2 into a sin square c by 2 plus a sin square a by 2 is equal to a into 1 minus cos c plus c into 1 minus cos a. So that is equal to a plus c minus of a cos c plus c cos a. And projection rule, by projection rule, that is a cos c plus c cos c is nothing but small b. So that is a plus c minus b, which is nothing but 2 into s minus b. So option number 3. Next, in triangle ABC, b cos square c by 2 plus c cos square b by 2 is equal to 1/3 a plus b plus c, 2 a plus b plus c, 3 half of a plus b plus c, 4 1/4 a plus b plus c. So b cos square c by 2 plus c cos square b by 2 can be written as half of b plus, that is b into 1 plus cos c by 2 plus c into 1 plus cos b by 2, which is half of b plus c plus b cos c plus c cos b. That is b cos c plus c cos b by projection rule, it is nothing but small a. So therefore half of a plus b plus c. So the correct choice is option number 3. So here also you have used projection formula. Understand? So all formula, see, we are studying, we are working out, but the problems, currency problems which require all this. So all the standard formula, using all these formula, we are working out the problems. Next problem, 49. In triangle ABC, if tan A by is equal to 5 by 6, tan C by is 2 by 5, then the sides ABC are in 1 geometric progression, 2 HP harmonic progression, 3 arithmetic progression, 4 equal. Now come on, see, tan A by 2 into tan C by 2 is equal to 5 by 6 into 2 by 5, which is 1 by 3. But now tan A by 2, tan A by 2 in terms of s and s minus a, etc. And you know that tan A by 2, sin A by 2 by cos A by 2. And sin A by 2 is square root of s minus b into s minus c by bc. Cos A by 2 is square root of s into s minus a by bc. So when you divide one by the other, you will get tan A by 2 as square root of s minus b into s minus c by s into s minus a into square root of s minus b into s minus a. Okay, we will come to the problem number 50. In ABC, if 2s into 2s minus a is equal to 3bc, then angle A equals 30 degrees, 60 degrees, 45 degrees, 120 degrees. By hypothesis, s into s minus a by bc is equal to 3 by 4. 3 by 4. So therefore, cos square a by 2 is equal to 3 by 4, because cos a by 2 is equal to square root of s into s minus a by bc. So cos square a by 2 is equal to 3 by 4, cos a by is equal to root 3 by 2. So a by 2 is equal to 30 degrees or a is equal to 60 degrees. So correct option is option number 2. For this problem also, we will work out by using a AMG inequality. In triangle ABC, the minimum value of z is equal to a by c plus a minus b plus b by a plus b minus c plus c by b plus c minus a is 1, 3, 2, 8, 3, 6, 4, 2 root 3. Now since sum of two sides is greater than the third side, in a triangle you know that sum of two sides is greater than the third side, we have c plus a minus b, a plus b minus c, b plus c minus a are all positive reals. So a greater than or equal to j implies z is greater than or equal to 3 into a by c plus a minus b plus b by into b by a plus b minus c into c by b plus c minus a whole to the power of 1 by 3. Also we know that a square is greater than or equal to a square minus of b minus c whole square. So b square is greater than or equal to b square minus of c minus a whole square, and c square is greater than or equal to c square minus of a minus b whole square. So therefore on multiplication, abc whole square is greater than or equal to a square minus b minus c whole square into b square minus c minus a whole square into c square minus a minus b whole square, which is nothing but a plus b minus c, b plus c minus a, c plus a minus b whole square. So ABC by a plus b plus c into b plus c plus a into c plus a is greater than or equal to 1. So 1 and 2 implies z is greater than or equal to 3. 1 is implies z is greater than or equal to 3. So minimum value is z is 3, and it occurs when a is equal to b is equal to c. And you can check when a is equal to b is equal to c, z is equal to 1 plus 1 plus 1. So correct option is answer number 1. Next, 52. This is a good problem. In triangle ABC, angle C is obtuse. Angle C, of course, in the diagram it's not like that, but angle C is obtuse. Angle C is obtuse, and G is the centroid. Let AD and CF, please see, AD and CF, I have not drawn that CF, be the medians of triangle ABC. If the points B, D, G, F are concyclic, then the ratio AC by BC is greater than 1 root 5, 2 root 2, 3 root 4, root 3, 4 equal to 2. The ratio is equals to 2. Now come on, see, for the triangle ACD, after drawing the diagram, ACD, AD square is equal to this median 1 by 4 into 2b square plus 2c square minus a square. Please remember that in any triangle ABC, the medians, if AD, BE and CF are the medians, then 4 into AD square is equal to 2b square plus 2c square minus a square. Easy to remember, 2b square plus 2c square minus a square. That means the median through A. And similarly, 4b square is 2c square plus 2a square minus b square, and 4 into cf square is equal to 2a square plus 2b square minus c square. Those are the lengths of the medians. The lengths of the medians formula. Please remember that is, and you note especially that median length formula. Now, BDGF are concyclic, and AB and AD, please see, AB and AD are sequence from A, and you know that for any circle from the outside point, if you draw two secants, the ratio is always constant. Understand? So therefore, AF, please see, AF into AB is equal to AG into AD. But that is half C into AB means small c is equal to 2 by 3 into AD into AD. AG is 2/3 C. AG is 2/3 AD because centroid divides the median into 3 equal parts. Understand? So the ratio is 2:1 from the vertex towards the base. So from that what you get is 3c square is equal to 2b square plus 2c square minus a square, or 2b square is equal to c square plus a square. 2b square is equal to c square plus a square, number 1. Also you have a square plus b square minus c square is equal to 2ab cos c, and you are given angle C is obtuse. Angle C is obtuse. So 2ab cos c is less than 0. So therefore a square minus b square minus of 2b square minus a square is less than 0, because we have substituted for this by 1. By 1 c square is equal to 2b square minus a square. So this shows that 2a square minus b square less than 0, or b by a is greater than root 2. B by a is greater than root 2. So correct option is option 2. 53. A vertical pole subtends an angle tan inverse 1 by 2 at a point P on the ground. If the angle subtended by the upper half and the lower half of the pole at P or alpha and beta respectively, then tan alpha comma tan beta equals 1 by 4 1 by 5, 2 1 by 5 2 by 4, 3 2 by 9 1 by 4, and 4 1 by 4 2 by 9. EAPCET 2012 this is. See, regarding properties of triangles, now in the present intermediate textbooks, there is no separate chapter for properties of, that is heights and distances. The heights and distances, they are the problems, applications of properties of triangle. So that's why a separate chapter is not given for heights and distances. Previous, unlike in the previous years. So 5 years back or 6 years back, there is separate chapter for heights and distances, but it's not there. It's removed the title because the problems, the heights and distance problems are applications of properties of triangles. So here regarding the problem, tan alpha plus beta is given to be half because this is AC is the pole and B is the midpoint of AC. So AC by AP is equal to 1 by 2. Tan alpha plus beta means AC by AP is equal to 1 by 2. So that we can take that AC as 1 unit and AP as 2 units. AP as 2 units. See, even though here I missed that as 2 units, but in the diagram I have written AP is equal to 2 because tan alpha plus beta is equal to AC by AB. AP is not, that is given to be 1 by 2. So you can take AC as 1 and AP is equal to 2. Now tan beta is AB by AP. Tan beta is AB by AP, which is 1 by 4. And because AB is equal to BC, AB is equal to BC, and also tan alpha is equal to, now you can write tan alpha is equal to tan alpha plus beta minus beta, which is tan alpha plus beta minus tan beta by 1 plus tan alpha plus beta tan beta, trigonometric formula. And now substitute the values of tan alpha plus beta and tan beta. 1 by 2 minus 1 by 4 by 1 plus 1 by 2 into 1 by 8, which is, so therefore, tan alpha comma tan beta is equal to 2 by 9 comma 1 by 4, because tan beta is 1 by 4. Tan alpha plus beta is equal to 2 by 9. So tan alpha is equal to 2 by 9. So the answer is tan alpha tan beta is equal to 2 by 9 comma 1 by 4. So the correct option is option number 3. So here what you have used is tan alpha plus beta, you got it, and tan beta also you got it. From the tan alpha you got it, because alpha can be written as alpha plus beta minus alpha. So correct option is option number 3. Because this is EAPCET 2012 problem, heights and distance. So because heights and distance are included in the properties of triangle, so for model's sake I am doing some problems. 54. If alpha, beta, gamma are lengths of the altitudes of triangle ABC with area delta, then delta square by r square into 1 by alpha square plus 1 by beta square plus 1 by gamma square is 1 sin square A plus sin square B plus sin square C, 2 cos square A plus cos square B plus cos square C, 3 tan square A plus tan square B plus tan square C, 4 cot square A plus cot square B plus cot square C. Again, this is EAPCET 2012. So here and you know that delta is equal to half BC sin A. So half BC sin alpha, and alpha is the altitude. So the is equal to alpha implies alpha is equal to 2 delta by A. Implies alpha is equal to 2 delta by A. Beta is equal to 2 delta by B. Gamma is equal to 2 delta by C. So delta square by r square into 1 by alpha square plus 1 by beta square plus 1 by gamma square is equal to delta square by r square into A square plus B square plus C square by 4 delta square. So that can be written as A by 2r whole square plus B by 2r whole square plus C by 2r whole square, which is A by 2r is sin A. So sin square A plus sin square B plus sin square C. So correct option is option number 1. So here we have used that area of a triangle is half base multiplied by the height. Okay. So with this we stop here. Tomorrow we again continue the continuation of the problems. So see, roughly in the 4 hours we want to cover a minimum 100 problems. I want to cover minimum 100 problems covering all the models, and you will come to the application of R1, R2, R3 are the x centers and x radii of a triangle. Of course, for EAPCET level, the x radii, x centers, and these projection formulas, sine rule, all these are the important one for EAPCET level. But for IIT level, there is also, you know, that what is called a pedal triangle of a triangle, and the distance between the x centers and in center, distance between the in center and the vertices for IIT side sake. But for you, EAPCET and mains, you will be having only these. The problems round up, they surrounding on the standard formula regarding the sides and angles of a triangle, and also in radius, x radius, circumradius, delta, everything. So we stop here today. Tomorrow we will continue the same topic.